Find the critical numbers of the function, the open intervals on which the function is increasing or decreasing, and the relative extrema. Relative extrema would be a high point or a low point on the graph. As always, feel free to graph these functions as necessary. Critical numbers are found by setting your first derivative equal to 0. Let's do that. Our first derivative is negative 6x plus 4. Setting that equal to 0. Add 6x to both sides. Divide by 6 and reduce. You get 2/3. That's our critical number, and there's only one of them. Okay, so mark off your critical number on a number line. Let's pick a number smaller, a number larger. Substitute these into the first derivative, which was back up here. Let's see, let me write this underneath, that way it does looks a little better. Our rate of change at 0, negative 6 times 0 plus 4, that's positive. Our graph increases in this interval. F prime of positive 1, that's our other test number. Negative 6 times 1 plus 4, that's negative. Let's see, I made a little boo-boo there. I meant to just write positive. There we go. That's a quick fix. And this one is negative. So our function is decreasing on this interval. Now, anytime you go from increasing to decreasing, you've created a hilltop at that critical number. Okay, so we are increasing from negative infinity to 2/3. On the other side of the critical number, we decrease. The rate of change was negative. Okay, so we've got our critical number of 2/3. We've identified the intervals of increasing and decreasing. And then our last part is the relative extrema. Because 2/3 is the only critical number, and it marks the location where increasing becomes decreasing, we're at a maximum. The max will occur at the function value of your critical number. Okay, so that value is -3, and this is the original function, 2/3 squared plus 4 times 2/3 plus 7. And if you break out your calculator, I think it comes out to 25/3. And that's where your maximum is located, at the point 2/3 and 25/3. There's only one critical number, and it represented a relative maximum. Because there's not another critical number to represent decreasing, switching to increasing, this one has no minimum. find the critical numbers of the function in the absolute extrema. On these problems, you'll be given a closed interval instead of just free range. You will have a function and a closed interval given. This one, we're supposed to analyze between 0 and 3. Let's get our critical numbers if there's more than one. First derivative. That's equal to 0 when x is either, I'm going to divide by 3, when x is either 1 or negative 1. Don't forget square root property. I'm going to mark both of these critical numbers off, but be careful. If you have a closed interval, like we have 0, 3, this number is not in that interval. So we only have to investigate this critical number and the endpoints of the closed interval given. So we're going to calculate f of 0, 1, and 3. F of 0, f of 1, because that's the only critical number in that closed interval. One minus 3, what's that, negative 2. And then the other end of the interval was 3. So you check your interval endpoints and any critical numbers inside of that closed interval. 3 cubed minus 3 times 3. What's 27 minus 9? 18. That's right. Out of all the answers, this one was the smallest, and 18 was the largest. So that's how you identify your absolute max and min, your absolute extrema.